All right, howdy folks. Here's what I have. I've opened up Desmos here, desmos.com, and what I'm going to do is I'm going to graph the sine function. So I'm going to type in y equals sin, that's sine, parenthesis x, close parenthesis. I'm going to change the color here. Let's go with, let's use purple, that sounds like fun. All right, and here's what I have. This is the function sine of x. Now, what I want to show you here is that you'll notice at 0 that if you go to the origin, that the sine function actually starts right at 0, 0. And then it goes up and then down and then up, and then it meets back, it finishes its rotation of up, down, up right at 2 pi. Okay, so that's one full rotation. So it's almost like an N shape. Now, there's three kinds of transformations that I'm going to show you. The first kind of transformation is a transformation where in front of the sine, where we multiply sine by a number in the front. So let's say we instead of having sine of x, we have 3 sine of x, so 3 times sine of x. And as you can see, what that does is it makes the graph go higher and lower. It doesn't change where the zeros are, it just makes the graph swing higher, has a higher maximum and a lower minimum. And you can see if I make the number, whoops, and if I make the number even larger, 4, it gets even larger. If I make it even larger, whoops, hang on a second, y equals 5 sine of x, there we go, then it's even larger. But I'm going to get rid of that number for now, so we're going back to the original sine graph. Now the second thing that can happen to the sine graph is it can shift up or shift down. Now if I add a number to the end, so like if I go plus 4, it shifts it up. If I put minus 4, it shifts it down. And that's what happens on the very end. If we either add or subtract a number at the end of the function, it will shift it up or down. Right now it says minus 4, but if it was minus 3, it would look like this. If it was minus 2, it would look like this. Minus 1 would look like this. And if I didn't have anything minus, then it would be in its normal place, right there along the x-axis. If I add 1, it goes up a little bit. If I add 2, it goes up a little more. Add 3, up a little more. Add 4, add 5. So you can see that the vertical shift occurs at the, based on whatever happens at the end of the function. The third thing that can happen is this, is I can put a number inside the parentheses with the x. So right now it's 1x, but if I made it 2x, see what happens is it actually squeezed in. Instead of being spread farther out, it actually crunched together. In fact, if I make it a 3, it'll crunch together even more. And then as a 4, it'll crunch together even more, and then crunching more, 5, 6, 7, 8, 9, okay? And that's what happens when the number in the middle, with the x, the number inside the parentheses gets larger. Now, if I made it a smaller number, a number smaller than 1, if I put 0.5x, it would stretch out. Okay, and so, I don't know why, let's see, there we go. So now, let's say that I had a function, let's say that I had 3 sine of x minus 2. I want you to notice now that the highest point of the graph is at 1, and the lowest point of the graph is at negative 5. And one way that you can find the shift at the end, okay, you can see, if you go to the middle of it, you can see where is the line in the middle. Well, here it is. It's at y equals 2, or excuse me, negative 2. Y equals negative 2. Do you see that line now that I just put in? It goes halfway through. That line is the midline, and it is shifted down 2 spaces from the x-axis. So, and at the end of the sine function is a minus 2. So if I wanted to, if I shifted it down 3 more, if I shifted it down to negative 5, then that would put the midline down at negative 5 as well. You see that? Okay, so But let's go back to -2 here. And so when we look at this graph, the first thing we're going to look at is at the y-axis, okay? At the y-axis, right there, at the y-axis, is the graph in the middle? Is the purple line starting in the middle of the up and down, or is it at the top of the up and down? Because if the graph was cosine, it would start at the top of the up and down. Okay? So, but if it's sine, then it starts at the middle of the up and down. And you can go to Desmos yourself and you can try all this out. I recommend go to Desmos, type in sine, and just play around by putting numbers in and see what happens to the graphs. Okay, well, what if so this, because it starts in the middle of at the origin, well, at the y-axis, because at the y-axis, the graph is, whoops, wrong thing. I put x equals 3. I meant to put x equals 0. Because at the y-axis, the graph starts in the middle, it's the sine function. It starts in the middle, it goes up, then down, then up. If it was the cosine function, it would start at the top of the curve and then just go down from the y-axis. So that's the big difference between sine and cosine. All right, now, from where it starts, because from there, all right, that's what I wanted. Because the midline, because the highest point is 3 units up from the midline, and the lowest point is 3 units down from the midline, that's 3. That's how we know the amplitude, which is the number that's being multiplied in front of the sine. And because the midline, which in this case is, again, y equals -2, because the midline is 2 units down from the x-axis, that's why we have a -2 at the end. Now, there's one more thing we can change. We could put in a, let's say, a 2 in with the x. So this just became 3 sine of 2x minus 2. And what that does now is it shows, what that means is now there are 2 full cycles of the sine function. So it goes up, up, and then up, up again before it reaches 2 pi. So 2 pi is an important number here. Everything, look at 0 along the x-axis and then go to the right over to 2 pi. However many times you see a maximum and a minimum, that's a pair, a maximum and a minimum. However many times you see a maximum and a minimum between 0 and 2 pi. So how many pairs of maximums and minimums are there between 0 and 2 pi? Well, there's 2 of them. There's one right after 0, it goes up, then there's a maximum, then it goes all the way down, and there's a minimum. Then it goes back up, and there's a maximum, and then it goes all the way back down, and that's a minimum. Then it stops at 2 pi. Now, what if I put a 3 in there? Well, now we could count 3 up and downs. Up, down, or up, down, ups. Up, down, up, up, down, up, up, down, up, all the way up to 2 pi. So there are 3 sine cycles, and therefore there's a 3 inside. So that's how you interpret these functions. If it was a cosine function, or that's how you interpret the graphs. If it was a cosine function, what if it was 5 cosine of 4x plus 1? Okay, I know it looks kind of crazy here, but here's what I want to show you. First of all, let me change the color here. First of all, notice that the middle of the graph is at +1. Okay, And again, now one way you can find the middle of the graph is take the y value, the highest y value, which in this case is 6, subtract, no, I'm getting that wrong. Oh, add the lowest y value, add them together, so 6 at the top plus, and then the lowest point is -4. So the highest point is 6, the lowest point is -4. If you add those together, 6 plus -4 is 2. Then divide by 2, and that gives you the vertical, or that gives you the midline, which is the vertical shift. Okay, so in this case, there's the middle line is at +1, so that means there's a +1 at the end of the function. Then if you want to find the amplitude, the highest number, you would add the top number, you would subtract the top number minus the bottom number. So 6 at the top minus -4 is 10, and then divide that by 2 again, and that would give you the amplitude. So 6 minus -4 is 10, divided by 2 is 5, so the amplitude here is 5. And then we've already said, okay, so this is cosine, and it goes, now cosine, instead of going up, down, up, it goes down, up, and however many times it goes down, up, that's the frequency. However many times it goes down, up from 0 to 2 pi. So down, up, that's 1, down, up, that's 2, down, up, that's 3, down, up, that's 4. So the frequency here is 4. And so the function is 5 amplitude cosine of 4x in parentheses and then +1. Okay, so I recommend you go to Desmos and you play around with this, and you can start to get a feel for the patterns. I hope this helps, and have a good day.